Okay, good morning, afternoon, or evening, everybody. Welcome to the NASA SeaDAS Enabling the Study of Our Planet from Space NASA Earth Data webinar. This is your host, Jennifer Brennan. While everybody is logging in, you have two optional polls at the bottom and middle portion of the page, and we certainly appreciate your feedback on these. I do have 2 p.m. Eastern Daylight Savings Time, so let's go ahead and get started. First, what I'd like to do is touch upon a few housekeeping items related to this webinar. To ensure the best audio experience, the conference has been placed in silent mode. However, if you have any issues or you have any questions, what I'd like for you to do is enter those into the Q&A pod, and you'll find that located on the lower right-hand corner of your screen. And this works like a chat. This webinar is being recorded and will be posted to our online Adobe Connect webinar catalog, as well as to our NASA Earth Data YouTube channel, usually within a couple of days of completion, and I do plan to provide that URL to all of you at the end. In addition, all presentation files will be available for download at the end of the webinar. As far as timing is concerned, this webinar is going to be 1 hour long. We've allocated 45 minutes to the presentation and live demonstration, with an additional 15 minutes for the question and answer period. After our speaker has finished his presentation, what we'll do then is we'll move to a final set of polling questions, and from there, we will transition directly to the Q&A period. Remember, you do have an opportunity to ask your questions throughout all portions of the webinar, with the exception of the live demonstration by using the Q&A pod. Questions will not be answered using the raising hand function. It has been disabled. And one final note. Depending upon the volume of questions that we receive, we will extend the Q&A period an additional 15 minutes to 3:15 p.m. Eastern Time for those of you who may wish to stay on the line. What I'd like to do next is move to the agenda, so let me go ahead and pull that up here. During today's webinar, our speaker will start off by providing an overview of the SeaDAS application. Next, he will transition to a series of SeaDAS-produced images that showcase the capabilities of the SeaDAS tool. From here, what we'll do is we'll transition to a live demonstration. With that, it is my pleasure to introduce today's speaker, Danny Knowles, who is a software developer and remote sensing scientist for the NASA Ocean Biology Distributed Active Archive Center, or OB.DAAC, at Goddard Space Flight Center. Danny?
Thank you, Jennifer. And welcome. We're going to talk about SeaDAS today.
Danny, can you see your slides?
Yes, I now see the slide.
Okay, wonderful. Take two.
Take two, here we go. Okay, SeaDAS, enabling the study of our planet from space. SeaDAS is software which does just that. It's free and publicly available by NASA, and it can process, visualize, and analyze remote sensing data. This is what it looks like, and we'll talk more about this shortly, just to give you a picture of what it looks like. This is loaded with a VIIRS image. VIIRS, and I will talk about the satellites shortly. Here's an overview of SeaDAS. Essentially, we have satellite data, which is acquired remotely, sensing the Earth. And on your computer, you can load the satellite data in the SeaDAS. You can also load field data in the SeaDAS. Field data is measurements that are made in the water, soil samples, anything like that can be measured as well and loaded in the SeaDAS and used in conjunction with the satellite data to compare the field data with. SeaDAS itself has a processing component, an analysis component, and a visualization component. And what it produces is products. You'll get chlorophyll, sea surface temperature, and a variety of other products. You get images, and it creates statistics. And the importance here is you can actually use essentially raw satellite data and process all the way through and get this out with SeaDAS. Its existence and significance. So why does such a program exist? Because it's very useful and it's free. Well, NASA has as one of its key strategic goals to advance an an understanding of the Earth. And SeaDAS fits under that. And what our goals at SeaDAS are is to provide the user community with the tools to work with supported satellite mission data, to produce all standard products like chlorophyll, sea surface temperature, and to continually evolve with technology. A key thing about SeaDAS is it's open source, it's free, it runs on standard desktop and laptop computers, and data is freely available as well. The user community is scientists, and to be honest, anybody can use this. It can be even used by children. It's a very wonderful tool, easy to use, but has a lot of depth, which can be used more extensively. And it supports 16 remote sensing satellite missions. This is very significant. Here's a list of the missions it's supported currently, and we have more coming. The current version is 7.3.2. I won't go into what all these mean, but you can look each of these individually up. A lot of them are acronyms, but I treat them as brand names, entities. I just think of it as SeaWIFS, Aqua, and I don't worry about the acronyms myself. Remote sensing data levels. This is, in case you don't know about these, the raw data out of the satellite is at level 0. SeaDAS, you can process this level up to 1A. At this point, you've added time and location information into your grid of data. The next level is 1B. At this point, you've radiometrically calibrated it, added instrument calibrations in. The next level is level 2, and this is the most popular level, I think, to use, because at this point you have your geophysical variables added, like chlorophyll and SST. Sorry. The next level is level 3. At this point, you can take multiple level 2 files or a single one, and you can merge them together and map it. Level 3 has 2 forms, a binned form, which is equal area. Every pixel covers an equal area of the Earth. And a mapped form. This is a standard map projection. You'll see an example of that shortly. All right, so let's look at some images which I've created using SeaDAS. This image was acquired from the MODIS Aqua satellite on the 10th of October, 2010. What we're seeing here is a true color image. A quick reminder about the spectral colors. Different wavelengths come into create different frequency that creates different colors. So your blue bands, essentially 450 to 495, so a reminder of that range of your electromagnetic spectrum. The longer wavelengths are infrared. So every satellite in general, especially MODIS, we're talking about right now, for every image that you view, you're actually seeing simultaneously about 40 or many different bands which have been separated out into various wavelengths. And by convolving all these wavelengths together, you can determine what you're looking at and create true color images. So for this, I've used for MODIS, the 469, the 555, and 645 as my blue, green, and red, respectively, to create this true color image. And in case you're not familiar, the big difference is between this and a picture would be maybe you're right there taking it simultaneously of everything. Whereas MODIS, it's imaging, the instrument is down there to the south, and it's slowly moving up. And as it moves up, it's scanning from right to left. So after 5 minutes, you get up here, and you've assembled all this into a single image that you can then load into your SeaDAS as the file. So what we can do with True Color is we can enhance it, just apply a different algorithm. I'm not going to go into it, but this basically, I enhanced it separately for land and for water. And if I could toggle back, you can see how it brings out the land and water features. Get used to using that pointer shortly. Another thing you can view is chlorophyll. Chlorophyll basically helps you measure the phytoplankton in the water, at the bottom of the food chain. There's an equation here. You don't need to worry too much about it, but this is done behind the scenes for you to create this. Now on the right, I've put another variant of chlorophyll. It's the same data and the same mapping, but to the right, I've used the common rainbow palette, which maps low chlorophyll to high chlorophyll with these values. And to the left, I've used a universal palette, which is colorblind compliant, again, from low to high. And the key is here that all colorblind people can see this correctly, whereas the rainbow one cannot be seen correctly by colorblind people. So it's one to consider, and it is available as default in the SeaDAS application, as is the rainbow palette. Moving on, another product of this scene is KD490. Essentially, this is the clarity of the water, where your blue values are very clear water, and where you get up to the 1, it's the opaque, less clear water. The next one is sea surface temperature. Not all missions provide this, but MODIS does, VEERS does, and this is using an infrared band to determine the temperature of the water. You're determining the temperature of water from space, so you're only seeing the surface. This is why we're calling it sea surface temperature. Now another thing you can do in SeaDAS is add bathymetry to this. The bathymetry isn't actually measured by the satellite itself, but satellite has the geography of where this is located, so using ancillary data, you can determine the depth of the water. Here we have a scaling that goes from 10 meters to 11,000 meters. We can adjust that scaling to go from 5 meters to 100 meters, and this depicts the shallow water features a little better if that's what you want to show. It's a nice area off the Chesapeake of the shelf. Another thing I can do is add a contour line. I put this at 25 meters. This is arbitrary selection, but it's to illustrate this point. So this is a contour line. So a 25-meter isobath means the line runs along 25-meter deep water. And I can go back into the chlorophyll image and overlay the bathymetry 25-meter isobath line. Another thing I can do is mask. So for depths less than 25 meters, I have my mask in purple. And what I would do with this mask, I can apply it. I can apply it as an exclusion mask, where I say for water that's shallower than that I want to get rid of. So if it's in the mask, I'm not going to use it. So this shows chlorophyll only where it's deeper water, greater than 25 meter. And conversely, I can use the mask as a region of interest mask. In this case, the depth of the water is less than 25 meters, then I show the chlorophyll. Another way to mask is to create a shape file. Here, I wanted to show just the Chesapeake, so I drew a polygon over the Chesapeake. I exported it as a shape file, and I can import it into any other file as a shape file. So essentially, this shape file is my mask when it's imported into SeaDAS. So I use it as exclusion mask here. So I'm showing all chlorophyll that's outside the Chesapeake. And here is the chlorophyll as a region of interest mask applied that's inside the Chesapeake. Another thing I can do is add grid lines, illustrated here. And moving over to another scene, this is the scene of the Himalayas, and this is back to using a red, green, and blue for the true color, the natural looking true color, where I'm essentially going red to red, green to green, blue to blue. It's a natural true color. Down at the below the bottom, sorry, this is just extra information for those who know about this. It's just more reference material. Sorry. So these are the MODIS bands used. These are the Landsat thematic mapper equivalent bands, and then these are the Landsat 8 OLI equivalent bands. In case you've been using those, then you'll know what this is referring to on these band combinations. I can enhance the land, just a different algorithm applied with the same band combinations. This sharpens the land, darkens the water, and saturates the cloud. That all depends on your selection of your algorithm. I'll toggle back. This is the natural color, that way that I would normally probably see it. And this is sharpening of the land. Now, another thing that's nice to do with band combinations is you can choose different areas of the electromagnetic spectrum to use for your red, green, and blue, essentially lights that get triggered. So here we're using a near-infrared, a red, and a green. And when you do this, the vegetation ends up being in red, vegetation in red, the soils in brown, and the cloud, ice, snow is in white cyan. And this can be used for vegetation studies, soil patterns, crop growth, monitoring floods. Another band combination, which is really nice, is using blue and the two shortwave IR bands. In this case, I use 1240 and 2130. In this case, I can separate out the snow here in the kind of orange peach color from the clouds, which are in the white. If I toggle back, you'll see previous combinations you cannot delineate between snow and cloud, but the final combination that I'm showing you here does. So all these different band combinations can help you delineate different features of the land and atmosphere. This is a very interesting picture here. This is a mapped image. What this is SeaWIF's instrument. This is 9 different files. There's one file here, and so forth to here that I've stitched together in SeaDAS and then mapped. The way this kind of illustrates nicely how a remote sensing satellite works. So this was SeaWIF, so it starts up here and is in a polar orbit. As it comes down, it crosses at local noon. From this point up here, it's tilted northward to avoid sun glint, and at this point, this empty space. Down here, it tilts southward and continues down. When it comes back around 100 minutes later, the Earth has turned just a little bit, and so its next sweep down hits along here, and so forth. So it'll keep going until it ends up here 9 orbits later, and it crosses Goddard Space Flight Center. And at that point, it downloaded the data. It recorded all this data on the recorders, downloaded it. We took the data and then spliced it out into 9 separate files, and these separate files then you can get and put them back together. All right, let's take a look at data comparisons. You can compare data in SeaDAS. So here we have a scene from MODIS Aqua. The area that's highlighted is better resolution data, essentially. It's a sensor zenith angle of less than 40 degrees. Here's SeaWIF. Again, I highlighted the area of better resolution data, and I put them together. did this in SeaDAS to do a comparison of Modus Aqua to Modus Sea, to SeaWIFS, and we get a good correlation here. I do the statistics, advance forward, the Aqua versus SeaWIFS, and we see the main differences are where you have big gradient areas, like especially along the Gulf Stream and coastal areas. And that's to be expected because the footprint on the ground for any single scene of different instruments is going to cover different space. Another nice illustration of what SeaDAS can do is, this is ship track. Essentially a ship did a cruise, and these are stations where it made measurements, and at certain points when it made measurements there was simultaneously satellite data available. The clear shows stations where it was within 3 hours. So it went through its course, and all this data I loaded into SeaDAS. And these are stitched together 4 different satellite scenes, which were simultaneous with the ship measurement. And I got some statistical results comparing the cruise measurements with the satellite measurements for chlorophyll. And the last slide is just a quickie I made from after the blizzard occurred. We had a nice cloud-free day over United States East Coast, and this is the snow left behind by the blizzard. The interesting thing about this is it's so cloud-free I was able to stitch 2 satellites together. To the right is Modus Aqua, to the left is Modus Terra. And by stitching the 2 satellites together, it made a nice true color picture and covered a greater area than any one satellite could have done. Now let's go to the live demo mode. My goals are basically to show the ease of use of SeaDAS, the speed and visual presentation. So I'm not going to treat this as a tutorial. There's just not the time. I just want you to get the feel of what can be done with SeaDAS and at the speed that a user probably would be doing this. Later you can go at your own pace and replicate this, because this will be on YouTube and you could follow along with SeaDAS open. And you can always ask us questions. So understand we want to talk about what SeaDAS can do and not the details of how to do it necessarily. So a quick outline, we're going to show how to download SeaDAS, how to get help, and then we'll do a case study. We'll show getting level 1A data from the web, level 2 data, and we'll do several of these things to a scene that we've already seen before. And then if I have time, I'll do a few other little case studies. And with that, let's get started with the live demo. SeaDAS 7.3.2, up here in the help, links to the web I'll show you shortly. But first I'll show you the internal help pages. And the main thing here, you can basically find whatever you need. We try to keep this as up to date as possible. We have release notes here, which is nice. Depending on what version you are on, you can find out what has been added in later versions, decide whether you want to use them. Another nice one I've added was the universal palette. So this shows how with the universal palette, it's compliant with colorblind people, and for the rainbow palette, the problems that occur. Moving on to the web pages, I'd like to point out you can get to the NASA Ocean Color web page, where a good resource for getting data, the SeaDAS homepage. This page here is where you'll download SeaDAS. So if you go to download, you can select, and it'll download very quickly. And be sure to check your system requirements if there is a problem, because that could end up being a problem if it's the first place to look. Back to SeaDAS, and another help is the video tutorials. Right here are some video tutorials that you can watch, made by yours truly. I need to get back there, okay. And lastly is the forum, web forum. So this is a very good resource to ask questions, post your questions, and we and other users respond quite quickly actually to these. So let's get started. I'm going to go get some data, show you how easy this is to do, how quick it is. It should be easy once you get the feel of it. So I'm going to get October 10th, and I'm getting a level 2 here. Like I said, if I've gone too quick, you can always go back and review this. So here are my level 2s. I've got the raw data, the level 0. I've got the level 1A. I'm going to grab that. I'm going to get a level 2 ocean color and level 2 SST. Go back into SeaDAS, my downloads, and let's go ahead and load these in the SeaDAS. Get my SST. Sorry, always SST, drag it over and drop it. And we can open this up. I see this is the Ocean Color Suite. See all the products available in there. Open chlorophyll real quickly. So in a very short time, I mean literally seconds or minutes, I've gone and grabbed data from the web and loaded it in SeaDAS. Take a look at SST. I'm viewing a separate file, SST, currently. I can tile these horizontally. I can synchronize them together. And I can do more with this, but what I want to do is go farther with this. I want to have a single file which has chlorophyll, has SST, has some other products that I want to use. So instead of going over these more, I'm going to go ahead and make a new level 2 file. To do that, I go to the multi-level processor over under OCSSW. I'm going to select the level 1A that we downloaded. And I'm going to make a geo file and a MODIS level 1B. And I could make the level 2 at this point, but I'm not going to do that because I want to customize this a little more mission specific, and I want to illustrate that. So I'm going to run this, or I'm not going to run it actually because I already ran it. I don't want to waste the time doing that, but it doesn't take long to run a lot of these. Then when I ran that, I came up with this file here. Give it a second to load. Open it up, and here I've got my chlorophyll and SST. And again, I can tile them horizontally, synchronize them together. And let's go ahead and talk more about this. So with chlorophyll, I want to add a color bar. I can do that. Again, I may be clicking too fast, but I'm clicking the speed that I would do it as a user. So just get the idea of what I'm doing. I can put on no data. I'll toggle that on and off. So this is where there's no data. And I can do the same with SST, with the exception that for SST, I want to change the color range. So currently the color range goes from -2 to 45. That's okay, but I want to change it, customize this to go from 10 to 35. Just makes a little better use for that scene of the dynamic range of the color palette. On SST, I'll go ahead and put some no data on. And for each of these, I can put some land in. And I prefer to have a gray land, chlorophyll. I'll put my land on that. And I'll get a color bar. Put the color bar under SST. Now I have chlorophyll and SST. We notice over here in the pixel info, so we see everything clearly, chlorophyll and SST. If I hover the cursor click on it and then see it, engage it. So now we see the chlorophyll value simultaneously with the SST. Let's minimize the chlorophyll. And now I'm going to create a new band. So what I want to do, currently this SST is in Celsius units. So I want to make a new band that's in Fahrenheit units. I'll call that SST Fahrenheit and give it the units of degree Fahrenheit. Edit expression, and I'll find the SST band, and I just multiply that by 1.8, add 32, so that's my conversion from Celsius to Fahrenheit. Click OK, and voila, I've got a new band. The colors currently are thinking it's scaled at the Celsius range, so I just have to modify the min and max to the values that it would be for Fahrenheit. Go ahead and add the color bar to this down here in Fahrenheit, and I will put some land and no data on this to finish this up. I'll toggle between the just open them both up. I'll tile them horizontally. How about that? And then we have SST in Celsius, SST and Fahrenheit. Over in this area here, you can simultaneously see under the pixel the Celsius and Fahrenheit value. All right, let's go ahead and we created that band. We can just as easily delete that band. So let's do that just to show we can do it. And now let's reproject this. Currently it's unprojected. This is a level 2 file. So to reproject this, go over here to this icon, which is a flying saucer looking icon. It's the best I could do. So here we have the file that we're going to create, and by default it's generic lat lon projection. So essentially it'll be vertical lines for lat and lon. So this is standard map projection. Might want to go bilinear to get better results, whichever, and then we can run it. I'm not going to run it because I already ran it. But before we do that and look at those, we're going to do two other projections. One is the Lambert azimuthal equal area. This is a very good one for statistics. And in this case, we want it centered over the scene. So I happen to know that my Chesapeake scene is centered at these values there for latitude and longitude. Say OK, and some people don't realize that you can adjust the resolution as well. And I will adjust the resolution up to 2,000 meters, and I do that especially for statistics because most of the pixels in this image are not at 1 kilometer resolution due to the high satellite zenith angle, the variations there. So press OK, and it's ready to run, and I can create that. And another one that's good that I'll show you is the oblique stereographic. This one here, again, same thing, set up the projection parameters. So take a look. Created all these. Look at I'll open each one. They've been opened recently already to show you. Got the Lambert and the oblique stereographic projection. Take a look, and this time, so I show you all the data, we're going to take a look at the green band. So this is the surface reflectance at 555. Take a look, and here's your reprojected data. Go back to the unprojected, but on the green band, so you get a good feeling for the difference. That's projected. Show some map grid lines to give you a good feeling of what the difference is when you reproject the scene. Go into the Lambert, which again would be an equal area projection, good for statistics. We'll look at the green band, get a projection. And this is a very nice projection. Compare that with, you can definitely see the difference in shape. Finally, I will look at the oblique stereographic, which is a projection that is probably one of the best ones for how the Earth would actually look if you were above that area. So it's a more accurate one visually. If I compare between the two, this is Lambert and this is oblique stereographic. They're pretty close, just minor angular changes are occurring. What did she say? Okay. Sorry, I just saw a message on the screen and asking me to do something. I didn't see what it was. It just threw me off. Hold on a second. My line of functioning. So for the Lambert, we could do a statistics on this. Let's go ahead and do a chlorophyll image, and I can draw a little polygon of sorts and do a histogram of that area. I can select the geometry, and I can run that, and I get a histogram of the statistics of that area. And I could do statistics over here as well. Select the area of interest and get statistics there of that scene. Close that. And another nice thing you can do, let me close this one, and we can look at chlorophyll in the regular projection. And with this one, I can throw on the NASA Blue Marble, fade away, get an idea of where it is. Sorry, I forgot to click on the hand. You can get an idea of where it is on the Earth. The one problem here is that this data here for chlorophyll is not temporally in sync with the data for the land. So another approach to doing that, I'll close this, is to make a true color image and stack the chlorophyll on top of the true color image. So in my oblique stereographic one, I will make a quick true color image. I have the true color image right here. I want to stack chlorophyll on top of this. And if I do this directly, there's holes in the chlorophyll, and some of this will bleed through the sea information. So what I can do is I can make a mask. I select land, and I'm going to make the complement of the land, because I want to get rid of everything that's not land. I'm adjust the transparency of this mask and get it onto a gray color. And now I'm viewing land with a nice gray canvas upon which I can lay my chlorophyll. So let's do that. I'm going to go to my layer stack. I'm going to add another layer. I'm going to add that. Before I do that, I need to open the chlorophyll band so it gets initialized with all the colors. And then I will go ahead and stack chlorophyll on top of this. And we'll notice we don't see it yet because it's in the stack, but it needs to be moved up in the stack. And there we go. We got a nice chlorophyll overlaid on the true color. And I can add in the cloud ice we want to see some clouds. And what this would have looked like if I didn't put that gray land there is you would have that. And that might be okay, but you do have things bleeding through that you may not want. So still have a few more minutes, so I think I'm doing good. I got through the first case study, which I was hoping to do, and I could do a whole lot more, but I think I'll do real quick here. I want to show you, because Landsat's just so neat with the high resolution. Let me show you that real quickly. To get Landsat data, over here, Earth Explorer. So basically, if you want to get Landsat data, you go to Earth Explorer, and you can pick the scene you want. I picked this scene, and I downloaded it, and I got that GeoTIFF file. Then I processed it using OCSSW processors, and then I get this image here. Don't have much time, so I'm going to show this super quick. I'm going to make a true color image of this. This is the Chesapeake Bay, and this is the Chesapeake Bay Bridge, actually. I'm going to align this pixel resolution of my screen, and what's pretty cool is you can, it's just at 30 meters resolution, you can delineate the spans of the Chesapeake Bay Bridge, which I just learned was the William Preston Lane Jr. Bridge. It has a name, and we see the clouds over here and the cloud shadow, and there's a lot of glint, and you can see all the boat wakes stuff. So it's not great for chlorophyll, but this particular image, but there it is, just in case you want to see it. And lastly, I'm going to end the demo with one last image, if I still got it here. And this is what I'm loaded in here is actually a JPEG. You can just load any JPEG or any PNG picture you want. So I just want to illustrate this. So what picture did I choose? Well, this is a picture of the two of us. This is not me, the two of us, but this is a tribute band, and this is Gene Feldman here. Gene Feldman and Chuck McLean were the original, essentially, founders of this whole SeaWIFS and SeaDAS project, and key people still. And you can certainly, since this is Beatles tribute band, you can put a color scheme on this picture. And that concludes the live demo portion of SeaDAS. We'll end with a couple slides. Jennifer? I do. Thank you.
Very good.
All right, so SeaDAS, then and now, just a quick history. 24 years ago, SeaDAS was started. This has been here a long time in its inception and planning phase. Chuck McLean and Gene Feldman started this, and it was made to support SeaWIFS. And at that point, you get data, and the question is what would you do with this data? It's not very accessible. Well, SeaWIFS launched in August 1st, 1997, aboard a Pegasus, and this is an image of that launch. Well, SeaDAS went active, and 8 days later, SeaDAS 3.0 Beta 3 supported SeaWIFS. So only a mere 8 days later, and we fully supported SeaWIFS. Since then, we've gone, originally we were IDL based, we are now Java based at version 7.0, and we now support, well, sorry, at that point we supported 14 missions, this milestone of 7.0, and 7.0 is a big difference than the earlier IDL versions, and this is interesting because it's a collaboration between NASA and Brockman Consult over in Germany, and they make the Beam. Theirs is the Beam software for Maris, and so a lot of the code is shared, and there's a lot of collaborative effort going on behind the scenes. Future SeaDAS 8 will also be Java-based, not too terribly different actually than 7, and this will be in conjunction with SNAP for Brockman Consult, which is similar to the BEAM, and this supports Sentinel-3, the ULCHI mission. So here's the current staff of the developers of 7, and this is everybody here. We're all here now, and special acknowledgments go to Brockman Consult. Karsten, Norman, and Marco have been enormously helpful in helping us here and adding code. And all the previous developers of SeaDAS are listed here. One big family here, and that's us. And the Ocean Biology Processing Group is a lot of people here that we're working together on this as well. And at this point, I finished 15 seconds earlier than I wanted, but I'm done, so I'll turn you over to Jennifer. Thank you very much.
All right. Thanks, Danny. Thank you, everybody. Thanks for being patient during our glitch there. And what we are going to do now is move to a final set of polling questions, and I'll give these questions just about 2 minutes or so, and from there we'll move directly to the question and answer period. For those of you who submitted questions throughout the slides portion, they have been captured, and I've been keeping note as to the questions, so we ought to be able to, kind of zoom in on those questions right away, and we'll do that in just a couple minutes. So thanks so much. So the feedback for potential future topics is really excellent. Perhaps in the future we can organize with the OB.DAAC folks an additional webinar that may focus on some of these key functionalities and features that you have described here. It looks like there's quite a few people interested in similar future topics. We're going to give this just about 30 seconds or so more, and then we will jump to the Q&A. Okay, everybody, we're going to go ahead and move to the Q&A portion of the webinar. If you didn't have an opportunity to, jot something down, you can certainly feel free to email me at the jennifer.l.brennan@nasa.gov, and I will forward that information along to Danny. And just really quickly here, you can, on the left-hand side, see where the webinar will be posted to the online Adobe Connect catalog for all of our webinars. All the archived webinars are there as well. If you're interested in downloading the files, you can see at the bottom right of your screen the webinar in PowerPoint format. I've also got it in a PDF format as well. It's a smaller file, and then the agenda. So certainly, if you highlight, you left click on either of those files, you should be prompted with an opportunity to download. And with that, why don't we go ahead and jump into the Q&A period, since we lost a bit of time early on here. And if you would allow me to locate the first question. Bear with me for just one moment. I need to scroll down there. Quite a few. Okay, so one of our first questions was, what is the default resolution for the bathymetry data? So Danny?
That would be around 2 kilometers.
2 kilometers. Okay, great. Thank you. And then the second question, which I did answer as you were going through the example slides, was whether or not all of the examples generated were generated working through the GUI. And I said the answer was yes.
Yes, they were.
Okay, great. And then moving on to another question a bit later. So Barry, I'm not sure if I understand, because it said in the command mode. There was a question early on. Can you please clarify a bit more as to what exactly you're trying to get at? And then in the meanwhile, what I'll do is I'll move to another question here. Okay, so the question is, was the demo conducted using the Linux version of SeaDAS?
I did this demo on a Mac. It shouldn't vary with Linux, but if you mentioned command mode, I didn't do this command line, but a lot of this can be done in command line mode as well. But I did this in GUI mode when I created this in the demo itself.
Okay, great. Thank you, Danny. The next question is, do the processors have to be loaded on the Windows version?
Right now, we don't support Windows processing. We will shortly with virtual machines. So if you want to process, it will need to be Linux or Macintosh. But if you use already processed files, then you don't need the processors.
Okay, thank you, Danny. The next question is, when I process sea surface temperature data, normally it comes upside down. How can I correct that?
We would need to see. That's not normal, so we would need to see that. That would be something they need to post on the forum, the exact example, so we can replicate that and determine how that error is occurring.
Okay, so for this user, I will follow up with an email as well afterward and CC Danny, so the two of you can be in contact as to how to exactly go about posting on the forum, particularly if you're not already active within that mechanism from the OB.DAAC, okay? And then the next question is here, which is the best band combination for volcanic ash detection on VIIRS MODIS?
Goodness, that's pretty cool. I don't know enough about band combinations. That's, look more on band combinations, and you can certainly just post it on our forum. It's a good question, and a lot of scientists are on our forum, and they'll answer that. And we have scientists on our group that might be able to answer that. It would be interesting to know the answer. I'm a developer, so I don't know that, but I would like to know it, and thank you.
So I think one thing to note for everybody who's asking questions, Danny and also Dr. Jean Feldman will receive a copy of these questions, and so certainly any of the scientific questions that are not answered within this format, they'll be able to answer those offline with you as well. So not to worry, because they will receive the Q&A, okay? And then another question is, well, it's more of a combination observation here. So Daniel was going to demonstrate the GUI. I mostly use the command mode, which seems to be much different in SeaDAS 7 than SeaDAS 8. Excuse me, than SeaDAS 6. My apologies.
Yeah, it's SeaDAS 6 and below, and SeaDAS 7 are pretty much different. I mean, it's it's different.
Okay, thank you, Danny. And also for any of the OB.DAAC scientists who are online still, if you want to answer a question, you can unmute yourself, using the *6, okay? Everyone else, if you'd be so kind as to stay muted, that would be great. Okay, so the next question is, what is the estimated date for release for version 8?
Don't have a current estimate. It could be this year. Version 8 is certainly is tied to SNAP. So when SNAP comes out, there's an earlier version for SNAP, but when Sentinel-3 Ulchi goes live, SeaDAS will support it, and at that point, I'm sure they'll release SNAP. You can download that and check that out, because some of that will tie in to be in SeaDAS 8. There won't be a lot of differences, but some of the command line mode and the structuring will be improved in 8. I can't give you a precise date on that at this point, but possibly this year.
Okay, thank you, Danny. And the next question is, does the adoption of Python imply an API exists or is being developed?
Didn't listen to that. Repeat that, please.
Sure. So the question is, does the adoption of Python imply an API exists or is being developed?
You know the answer? It's being developed.
Okay. Thank you, Danny. And then the next question is, one moment here. Okay. Okay, it's more of a reply to something earlier. So I will read the reply. It says, combinations for specific purposes should be handled on an enhanced basis. For instance, if some wavelength reflects in a particular mode certain characteristics that we would want to study, and in other wavelengths the reflection is basically null, you combine the two wavelengths that have a final image in which the characteristic would show distinctively. Hope it helps.
Oh, that's a reply. Okay.
Yes, it looks that's more of a reply to a previous question, I believe, for perhaps the band combinations for highlighting volcanic ash, if I recollect properly.
Yeah, I would assume the answer would be which are the 3 bands that you use in the band combinations, but it could be something in where you said about the whether you fit it linearly or not.
Correct, is the reply for the band combination. Okay, so the next question for you, Danny, is it now under SeaDAS 7 is possible to use the OC/SSW routines by using shell scripts and even IDL. Will this be the case in SeaDAS 8?
I don't know about the IDL part. I can't answer that. Maybe you can. I don't know about the IDL. All of the OCSSW, SeaDAS is essentially an avenue where you can get all the OCSSW processors, and then you can install it through SeaDAS, and then you can run those directly from the command line, L2Gen, all these directly without even using SeaDAS once you've installed them with SeaDAS. That it all answers the question.
Okay, thank you, Danny. I am looking to see whether or not we have any further questions. And I'll give it just a couple minutes here. I don't see any further questions at the moment, but we'll wait to see if anybody has come up with some. What I will do while we're waiting here to see whether or not there are any further questions, generally what we'll do when we're finished with the Q&A period, and we are currently running into the extra 15-minute time slot, which is perfectly okay for those who can stay on the line, I will leave the meeting room open an additional 10 minutes or so after we're finished for those of you who may wish to download the presentation files prior to, seeing it posted online. And then, from there, we'll hang up the telecon, but we'll leave the virtual meeting space open. So certainly if you think of something, you can type that into the Q&A pod and it will still be captured. And I do see an additional question here. And so the question is it operable in images on land and land or rivers to evaluate? Okay, so can you use it for land images or rivers to evaluate oil spills and environmental damages?
Well, I would certainly think so, but it's beyond where I can answer that application. I would say that would be another one to post on our forum. It's more of a scientific algorithm of how you would acquire that.
Okay, and I'm looking here to see if there are any further questions. I mean, I would think that the fact that you had pulled up the Landsat data, that certainly you could be using other data products that would allow you to, within this application, that it would allow you to see or evaluate that type of thing.
Yeah, I would think so too. It's just knowing the exact algorithm you want to use. I mean, you can certainly visually see it by different band combinations, and all these can be loaded in. And I'd also like to point out that even though we fully support 16 satellites, tons of other satellites you can load in. It's just that we don't support it through the processing levels. But if you've already processed it and have the data that can be loaded in, you can load it in and work with it. And one thing I forgot, which is important, is a lot of people use SeaDAS just to get at the data and then use another software afterwards. So it's a good, and we encourage that. I mean, use whatever you're comfortable with, and it's a good way to get at satellite data.
Okay. Okay, so, and then there's a comment, Landsat images are supported. We'll give it a try with those images and we'll report if we have positive results. I mean, the other point to make, is that although this webinar is about the SeaDAS application, there are a number of different, data applications and tools out there. If you're finding that this particular software or application is not meeting your needs, there are 12 NASA EOS DAACs. Some of them focus specifically with, for example, Aster land products and Modus land products. And, those types of resources I can make available to you to connect with an individual data center if that is needed. So feel free to email me if necessary. And then the next question is, an old SeaDAS 6 batch processing scripts, are old SeaDAS 6 batch processing scripts able to be translated directly to Python?
We don't have anything currently to do anything like that. Unfortunately, SeaDAS, in our opinion, SeaDAS 7 is light years beyond 6, but it's different, and I don't. Unfortunately, it's just a complete change. It's like a whole new software in a sense. So it's unfortunate that it's not easy to transition from 6 to 7, but it was kind of necessary, especially with the increases that we have made with this collaboration with German company, Brockman. It's just a new package, essentially. And we no longer have the extra personnel that could support 6 at the moment. So if but that's the processors. If you're just talking about processors like L2 Gen, that's all similar. So if it's those, then it's not an issue.
Okay, thank you, Danny. And one of your participants has noted that, it might be light years beyond in terms of the GUI, but as you noted, the OCSSW processor still can be used.
Correct. And then they of course have advanced too. I mean, they continually do advance, but the inputs and outputs aren't changing as drastically as SeaDAS 7 has.
So thank you, Danny. So the next question, and we've got about 5 more minutes left of the Q&A period. As I said, we'll leave the room open. If you think of something, feel free to type it in. You're always welcome to email me with a question that I can forward along to our speaker today, and also Gene Feldman, who manages the Ocean Biology DAAC here at Goddard Space Flight Center. Or if you need data that or you have questions that really might fall a little bit outside of this topic, I can definitely put you in contact with the appropriate data center. So the next question is, I would like to know about sea surface temperature using the OLI instrument on Landsat.
We don't currently support that yet. I don't know when we will support it, so I can't give a when and if. So I can't give an answer on that. But we do not.
So I have a question actually for you, Danny. Okay. So this relates to some of the questions that have been asked earlier regarding future capabilities and so forth. So I'm assuming that these types of that you keep information on the website that would include updates for upcoming releases, for example. So how could one follow future development? Are there, is that something that you should be posing to the forum, or is that something one would follow by way of the Ocean Color website?
Yeah, the best way to keep up is on the forum. We have an announcements page, so you would go there and subscribe to the SeaDAS announcements, and every time there's a new release, we put what's in the release. But isn't that the forum? Sorry, I've been pointing out that there's a separate mailing list where you can subscribe on the forum as well.
Okay, and so just to confirm, because I'm getting ready to type your back website into the Q&A here. So for the mailing list, one would access that by way of the announcements page. Is that right, or on the home page?
It looks like they're both on the web forum.
Okay, so thank you.
And also with the announcements, not only do you get the latest releases, but you also get, if we're doing a webinar or a presentation somewhere, or maybe another key thing is the YouTube tutorials. You could always subscribe to that channel as well.
Okay, thank you, Danny. And so there's another question here. Is it possible to work with inland waters using SeaDAS? And how do you get rid of, I hope I've got this right, how do you discard the mask? And then the follow-up is, would OLI be the best option? But if it's not supported, I understood you saying, then that would not be the best option, correct?
Well, it depends on how big the inland waters are. If you want to get rid of the mask, there are ways of doing it. You could treat the whole world as if it was no land and just process this as if the whole world was ocean. And there are ways of turning the landmass off to make sure it processes. Probably best is to just post on the forum what you're trying to do, and will help you.
Okay, thank you. We've only got a couple more minutes left to the Q&A period. Does anybody else have any questions? All right. If there are no further questions, what we will do, okay, excuse me. As far as new seminars coming up, we are actually going to have, it's a totally different topic as part of our series. You can follow, keep track of all these on the, at the tinyurl.com to the left, Earthdata webinar. We've got one coming up on using space geodesy data, specifically for determining precise orbits with our altimetry data products, and that will be with our satellite altimeters, and that will be coming up on June 29th. So if you sign up to our webinar announcement email listserv, which you can find on the tinyurl.com Earthdata webinar, or you can check out our various social media channels. I'll usually announce them there. That'll be on June 29th again, and a different topic though. And then coming in July, we will have a webinar that focuses on NASA Worldview application, which many of you might be interested in. All right, so again, if there are no further questions, we will hang up from the telecon, and I'll leave the virtual meeting space open. And I'd like to thank all of you for your patience at the onset, and particularly with the... All right, everybody, we're going to hang up now, and hope to see you again in the future. Thank you, Danny. Thanks, Jean, everybody from the OB.DAAC group, and all of our participants. All right, bye-bye now.